Nobody told you this was coming. The satellites tracked it. The meteorologists watched it build on their screens in real time. The emergency alerts went out. And yet, millions of people were still caught completely off guard. Not because the warnings weren't there, but because nobody truly explained what a storm of this scale actually does to human life, to entire economies, to islands and cities that will spend years trying to remember what normal used to feel like. This is not a weather report. This is what happens when nature reminds civilization exactly how fragile it really is. There is a moment right before a major storm makes its closest approach to land when the world goes unnaturally quiet. The birds vanish, the ocean pulls back. The air pressure drops so fast that your ears begin to pop like you're descending on a plane. People who have lived through multiple hurricanes describe this moment the same way, every single time, as the specific silence of something enormous holding its breath. That silence is a lie, because what comes next is the full, unrelenting weight of one of the most powerful forces on this planet, arriving without mercy and without apology. In 2026, that silence has been broken again and again, and millions of people have been standing directly in its path. What most people are not seeing is just how extraordinary this year has actually been when it comes to storm activity across the entire planet. Not just one basin, not just one ocean. Every major tropical cyclone region on Earth has produced systems of terrifying power. And the stories behind each of them reveal something far more disturbing than any single storm. They reveal a pattern, a trajectory, a question that nobody in charge seems willing to answer out loud. Let's start with what just happened in Hawaii, because the images coming out of the Big Island right now are unlike anything residents there have seen in decades. Hurricane Lala swept south of the Hawaiian state just this past weekend, bringing torrential rain that triggered destructive flooding across multiple islands. On the surface, that sounds manageable. A storm passed nearby. Some flooding occurred. But here's where it gets worse. Read the actual numbers coming out of the ground. Over 3.5 feet of rainfall was recorded in the Big Island's mountains alone, setting off landslides and flash floods that wiped out roads and swept at least one home entirely off its foundation. 3.5 feet of rain. That is not a weather event. That is a geological rearrangement of an island. Think about what that means for a moment. Every road that got wiped out is a lifeline. Every bridge that collapsed is a connection between a community and a hospital, between a family and a grocery store, between an island's economy and the outside world. When those connections disappear under several feet of fast-moving water, the isolation that follows is not just physical, it is psychological, it is economic, it is a wound that will take years to properly close. Footage on social media showed floodwaters rising, overtaking roadways and bridges as the storm dumped rain on Hawaii's Big Island. Howling winds whipped the tops of palm trees and waterways swelled with fast-moving runoff from relentless rain that blew nearly sideways. But even that dramatic imagery didn't capture the full human cost of what was unfolding. According to informed sources on the ground, 2 homes were swept away due to intense rainfall, with flash flooding ongoing in multiple areas. Several occupied homes may have been swept off their foundations amid flash flooding, and the storm didn't even make direct landfall. Lala became only the 5th hurricane since 1957 to pass within 70 miles of the Big Island, according to NOAA's historical database. That detail should stop you cold. 5 times in nearly 70 years, and the island still took the full force of what nature decided to send its way. The wind gusts recorded across the mountainous terrain were extraordinary. Wind gusts from 50 to 90 millimoles were measured over the mountainous terrain of the Big Island, Maui County, and into Oahu. Instruments atop Mauna Kea, Hawaii's tallest mountain, measured a 154 mm wind gust early Saturday afternoon. 154 miles per hour on a mountaintop. That is the kind of reading that makes meteorologists go silent at their desks. And this is where everything changes in how you understand what a storm does beyond the immediate moment of impact. About 100,000 homes and businesses are still without power across the Hawaiian Islands as of Monday afternoon, after hurricane-force wind gusts swept across Hawaii, Honolulu, and Maui counties. Power restoration in certain areas could take days, or significantly longer, because it's not just about replacing a fuse or flipping a switch. Main lines must be repaired on the Big Island, Maui, and Oahu, according to utility company Hawaiian Electric. These are massive transmission infrastructure corridors that took decades to build and can be destroyed in a single afternoon by winds that care nothing about engineering achievements. Meanwhile, the human toll was crystallizing in the most heartbreaking way possible. In the wake of the storm, officials discovered the body of a 90-year-old woman who perished in the flood. A 90-year-old woman, the kind of person who had survived everything the world had thrown at her for nearly a century, who had outlasted wars and recessions and every storm that came before, and she was swept away by floodwater. That is what storms do when they come at full force. They do not distinguish between the strong and the fragile. They do not check credentials or spare the experienced. They arrive and they take. But here's what most people are not seeing when they watch storm coverage and feel the brief twinge of concern before moving on with their day. Hawaii is not a random data point. It is part of a pattern that is playing out across the entire planet with a frequency and intensity that should be commanding far more global conversation than it currently is. Go back to April of this year, back to a small chain of American islands in the Western Pacific that most people in the continental United States couldn't locate on a map without assistance. The Northern Mariana Islands, Saipan, Tinian, home to roughly 50,000 American citizens who live in one of the most storm-vulnerable positions on Earth. And in April 2026, they came directly in the crosshairs of the strongest tropical cyclone of the entire year anywhere on the planet. Super Typhoon Sinlaku formed southeast of the Commonwealth of the Northern Mariana Islands and Guam, two U.S. territories that make up the Mariana Islands archipelago in the Western Pacific. It rapidly grew to a Category 5, 185 mph monstrosity. Read that again, 185 miles per hour. That is not a storm. That is a weapon forged by thermodynamics and ocean heat, aimed at a small, relatively defenseless cluster of islands that had already survived Super Typhoon Yutu 8 years prior. Typhoon Sinlaku made landfall in the Northern Mariana Islands on April 14th as a powerful Category 4 storm, with sustained winds of 150 miles mph and recorded gusts reaching 185 mph. The islands of Saipan and Tinian experienced widespread power blackouts and extensive damage to homes and infrastructure, as well as heavy flooding from over 20 inches of rain. 20 inches of rain on islands that are, in some places, barely elevated above sea level. The math on what happens to such geography under those conditions is not complicated. The outcome is catastrophic and total. The powerful storm slammed into Saipan late Tuesday, lashing the island for hours with violent winds and heavy rain. By Wednesday, large portions of the island were without power and many roads remained impassable, but the details emerging in the aftermath painted an even more brutal picture. Images from Saipan showed neighborhoods strewn with debris, twisted trees, and damaged infrastructure. In Garapan village, floodwaters partially submerged homes and streets. And then there was a moment that crystallized the full human weight of what Sinlaku had done to Saipan in a single quote from a resident. Brian Manabat, a journalist on the island who sheltered in place with his wife and 4 children and sent voice memos documenting what he witnessed, said something that lingered long after the storm moved on. He described Saipan as devastated, noting that the economy is dependent on tourism and that it was hard to tell when recovery could even begin. Not hard to tell how long it would take. Hard to tell when it could even start. That is the hidden catastrophe inside every major storm. The storm itself lasts hours or maybe a day or two. The destruction it leaves behind lasts years. Typhoon Sinlaku caused total damage exceeding $458 million for an island of 50,000 people. That is not just a statistic. That is the complete reshaping of an economy, the wiping out of savings, the closure of businesses that will never reopen, the departure of residents who decide the repeated risk is simply no longer worth it. What most people are not seeing is that this is not chaos. This is a system, a planetary system, running hotter than it has in recorded history, producing storms that are becoming more intense even when they are not necessarily becoming more frequent. The real story is buried inside the climate science that powers these storms, and it connects every single event we've discussed so far into a single, deeply alarming narrative. Warmer oceans may contribute to an increased fraction of tropical cyclones that strengthen quickly, a process known as rapid intensification. From 1980 to 2025, 190 Atlantic tropical cyclones rapidly intensified. Nearly 1/4 of these storms experienced extreme rapid intensification, an increase in maximum sustained winds of at least 50 knots in a 24-hour period. Think about what that means for the people who live in a storm's projected path. A forecast that says a tropical storm is approaching your coastline with 60-mile-per-hour winds sounds concerning but survivable. Boards on the windows, sandbags at the door, maybe an evacuation for the truly vulnerable. But what happens when that storm rapidly intensifies overnight and arrives as a 130-mile-per-hour hurricane? The answer is that the gap between preparation and catastrophe becomes impossible to bridge in the time available. And that gap is now happening 1/4 of the time with the most extreme storms. And this is where everything changes, because the season that forecasters predicted in 2026 and the season that actually materialized are telling two very different stories. At the start of the 2026 Atlantic hurricane season, the experts were cautiously optimistic. NOAA predicted a below-average Atlantic hurricane season, citing a very strong El Niño climate pattern that was expected to create atmospheric conditions suppressing tropical development in the Atlantic Ocean. The models were pointing toward a quieter year, The atmospheric setup seemed favorable. A strong El Niño had already taken hold, with water temperatures in the El Niño zone more than 2 degrees above average, higher than the same point for other recent super El Niño events of 2015, 1997, 1991, and 1982. On paper, this should have meant relief. Fewer storms, lower intensity, a season where coastal communities could breathe slightly easier. But here's where it gets worse. El Niño suppresses Atlantic storm activity, yes, but it simultaneously supercharges the central and eastern Pacific. And that is exactly what happened. NOAA predicted an above-normal hurricane season for the central Pacific Basin, with a 70% chance of elevated activity and a forecast of 5 to 13 tropical cyclones, nearly triple the near-normal count of 4 or 5. The energy doesn't disappear. It shifts. It reorganizes. It finds the ocean basins where conditions are warm enough to feed it, and it builds. Hurricane Lala hitting Hawaii in August was not a coincidence. It was a direct consequence of the Pacific Basin running at elevated temperatures, feeding storms that would not have been possible to sustain just a few decades ago. The ocean is warmer, the fuel is more abundant, and the storms are taking full advantage. Meanwhile, the continent wasn't spared either. Because while the Pacific was generating historic storms and the Hawaiian Islands were counting their losses, the American heartland was facing its own reckoning. A massive 4-day weather system carved a path across the United States, threatening what meteorologists warned could be the most expansive outbreak of severe storms so far in 2026. Dangerous conditions began unfolding through a massive corridor from the Gulf Coast to the Great Lakes. AccuWeather senior meteorologist Courtney Travis noted that the atmospheric setup was particularly volatile, warning that the system had the potential to produce the most widespread and impactful severe weather outbreak seen so far that year. She pointed to a combination of strong, high-altitude winds, surging moisture from the Gulf of Mexico, and sharp temperature contrasts as the primary drivers of tornadoes, large hail, and destructive wind gusts. And the timing could not have been more punishing. The timing was especially concerning for communities in the central states and Great Lakes that were still reeling from the prior week's storms, which had already claimed 8 lives. 8 lives. And then another system arrived before the first one's wounds had even been properly counted. Forecasters issued a high-risk zone covering parts of Texas, Missouri, Illinois, and Iowa, the first time the agency had issued such a high-priority warning since August 2025. Major metropolitan areas including Dallas, Oklahoma City, St. Louis, Chicago, and Indianapolis all sat within the danger zone. Cities of millions of people, economic hubs that power enormous swaths of the American economy, all simultaneously under threat from the same converging atmospheric conditions. This is not an isolated bad week. This is what the new rhythm of severe weather looks like at a planetary scale. And the most dangerous thing about it is not the storms themselves. It is the compounding effect of back-to-back events hitting communities that never fully recovered from the last one. There is an economic concept that applies perfectly here, even though you will rarely hear it discussed in storm coverage. It is called the exhaustion threshold. It describes the point at which a population, a local government, an insurance market, or an infrastructure grid has been hit so many times in such a short window that it can no longer mount a full recovery before the next event arrives. Communities begin losing population as residents decide the math no longer works in their favor. Tax bases shrink, local governments can't fund infrastructure repair, insurance companies stop writing policies or raise premiums to levels that force out the middle class, and the cycle accelerates. The Northern Mariana Islands have been on this trajectory for years. Hawaii is dangerously close to joining them. The Gulf Coast of the United States has been living it for nearly 2 decades, and the data tells a story that should be making front-page headlines every single day. According to informed sources tracking global storm economics, total damage from tropical cyclones in 2026 has already exceeded $5 billion, with 142 confirmed fatalities across all global storm basins. And the peak of the Atlantic hurricane season hasn't even arrived yet. Climatological peak intensity typically extends from mid-August through October. The storms that hit Hawaii last weekend and the Northern Mariana Islands in April both occurred before the traditional window of maximum activity had fully opened. The real story is what happens when peak season arrives in a year where the foundation has already been weakened by months of sustained storm activity. Communities that would normally be well positioned to absorb a direct hurricane hit are already exhausted. Emergency response budgets are already depleted. Infrastructure that was functioning at 80% capacity before a storm hits will fail in ways that infrastructure at 100% capacity would survive. And this is where everything changes in terms of how we need to think about the storms still ahead. By mid-2026, the planet had already produced 4 Category 5 tropical cyclones. Sinlaku reached 185 km/h winds in the Pacific. Super Typhoon Bavi reached 180 mph winds in July. Hurricane Genevieve became the first Category 5 of the Atlantic season, 4 Category 5 storms before September. 4 of the most powerful class of tropical cyclone that meteorologists measure, produced by an ocean system that is fundamentally warmer and more energetic than it was a generation ago. The atmosphere is not behaving randomly. It is responding mechanically, physically, thermodynamically to conditions that human activity has fundamentally altered. The ocean surface temperatures that feed these storms are warmer because the water is absorbing heat that the atmosphere is trapping at unprecedented rates. The rapid intensification events that are making storms nearly impossible to adequately prepare for are directly linked to the depth and temperature of warm ocean water layers. And that depth is increasing every year. But here's something that almost nobody is talking about in the coverage of individual storms. The El Niño that is suppressing Atlantic hurricane activity in 2026 will eventually weaken. El Niño cycles are not permanent. They shift back to neutral and then to La Niña conditions, often within 1 to 2 years. And La Niña is the Atlantic hurricane's best friend. When El Niño fades and La Niña emerges, the wind shear that currently disrupts Atlantic storm formation collapses. The atmospheric brakes come off. And the ocean temperatures in the Atlantic, which are already warmer than normal even in a suppressed year, will be waiting with enormous amounts of stored energy ready to power whatever storms the season produces. Sea surface temperatures are above normal in the western tropical Atlantic even now, in a below normal year. This creates a mixed oceanic background state rather than a uniformly supportive warm basin. In other words, the fuel is already there. The only thing holding the Atlantic back in 2026 is the atmospheric pattern. When that pattern shifts, and it will shift, the fuel and the atmospheric setup will align simultaneously. That is, when the projections that scientists have been warning about for years will stop being projections. Consider the cascading logic of that scenario and what it means for communities that are already dealing with the aftermath of Lala, Sinlaku, and the severe weather outbreaks of 2026. The islands of Hawaii that are right now without power, rebuilding roads, assessing structural damage to over 100 homes, they will have approximately 12 to 18 months to complete that recovery before the next active season potentially arrives with the full force of an unshielded La Niña environment. The Northern Mariana Islands, which were still recovering from Sinlaku's $458 million in damage when their officials were already watching Tropical Storm Bavi form in the same waters in July, they will be doing the same calculation. How much can we fix before the next one comes? This is not pessimism, this is logistics. This is the cold arithmetic of storm recovery timelines measured against storm frequency trends, and the numbers do not align comfortably. What is particularly striking when you examine the global picture of storm activity in 2026 is how much of it is affecting American territory specifically. Hawaii, the Northern Mariana Islands, Guam, the Gulf Coast. These are not foreign nations hit by distant disasters. These are American citizens living under the American flag, and the burden of their recovery falls on federal disaster response infrastructure that is being stretched progressively thinner every year by the compounding demands of back-to-back events. President Trump issued a disaster declaration for the Northern Mariana Islands following Sinlaku, with FEMA deploying personnel and supplies to help with recovery efforts, and those resources were critical. But every federal disaster declaration depletes a shared pool of emergency capacity that is simultaneously being called upon in dozens of locations across the country for floods, wildfires, and severe weather outbreaks happening in the continental United States at the same time. The system is not broken, but it is being tested at a rate and scale that it was never designed to handle simultaneously. There's a broader geopolitical dimension to this that informed observers are beginning to discuss, even if mainstream coverage rarely connects the dots. American territories in the Pacific, Hawaii, Guam, the Northern Mariana Islands, are not just civilian communities. They are strategic military assets that sit at the center of American Pacific power projection. Guam experienced significant impacts from Sinlaku, including power outages and flash flooding, though it avoided a direct hit from the storm's eye. Guam hosts some of the most critical U.S. military infrastructure in the Pacific theater. When Guam loses power and floods, even briefly, the operational readiness implications extend far beyond the island itself. Think about what that means in a world where geopolitical tensions in the Pacific are at their most elevated in decades. A storm that disrupts military readiness at Guam, even temporarily, sends a signal, not intentional, not directed, but real, about the vulnerability of American strategic assets to natural disasters that are growing in intensity every year. Adversaries who maintain intelligence capabilities in the region do not miss these moments. They study them. They note the recovery timelines. They assess the gaps. This is not alarmism. This is the intersection of climate and geopolitics that defense analysts have been writing about for years in reports that rarely make their way out of classified briefing rooms and into public conversation. The storms that most people see as weather events are increasingly becoming strategic realities that shape the calculations of governments and militaries across the Indo-Pacific. And through all of this, through the flooding in Hawaii, the devastation in Saipan, the severe weather corridor cutting through the American heartland, the relentless parade of Category 5 storms crossing the global tropics, through all of it, the fundamental conditions that produce these storms are not changing in a direction that offers relief. They are changing in the other direction. The ocean is warming. The fuel is accumulating. Ocean temperatures in the western tropical Atlantic remain warmer than normal, and trade winds are likely to be weaker than average, both conditions that, in isolation, would favor significantly more storm activity. The only thing providing any restraint right now is the El Niño pattern. And as discussed, that restraint has a timer on it. So where does this leave us? Where does it leave the people of Hawaii, who are still without power, still filing insurance claims, still pulling debris from roads that used to connect their communities to the rest of the island? Where does it leave the residents of Saipan who watch their neighbors lose roofs and their neighbors' neighbors lose everything, who know that the same waters that produced Sinlaku are still out there, still warm, still capable of generating another monster before the season ends? Where does it leave the families in Dallas and Chicago and St. Louis who spent days sheltering from a severe weather outbreak that hit a region still grieving from the storm before it? The honest answer is, in an uncertain place. In a place where the warnings are increasingly clear and the preparedness gap is increasingly wide, and the political will to close that gap has not yet matched the scale of what the data demands. There is a version of the story where it ends with reassurance, where the meteorologists' models improve enough to give communities adequate warning, where infrastructure investment accelerates to meet the new reality of storm intensity, where insurance markets find sustainable ways to keep coverage available in the highest risk zones, where emergency response capacity scales to handle simultaneous multi-theater disasters without exhausting itself. That version is possible. The technology exists, the science is clear enough, the tools are available, but it requires something that storms cannot be convinced to wait for. It requires decisions to be made before the next warning goes out, before the next satellite image shows another unnamed disturbance organizing over warm water, before the next quiet that descends over a coastal community is broken by the sound of something enormous that has been building for decades finally arriving at the shore. The satellites are already tracking the next system. The meteorologists are already watching the sea surface temperatures. The emergency managers are already doing the math on resources and timelines and who will need what and when. The only question that remains, the one that nobody in charge seems willing to answer directly, the one that the storms themselves are asking every single time they make landfall, is whether the world watching all of this from a safe distance will decide that it has seen enough to change something before the next one arrives. Because the next one is already forming, and millions of people are already in its path.